Imagine hopping into your car, speaking your destination, then sitting back and enjoying the ride while your car drives itself. No traffic jams, no finding parking spots, just smooth sailing wherever you want to go. That's the promise of self-driving cars. Pretty cool, right? The tech is still evolving, but companies like Tesla are getting us closer every day. So how do these robot cars work their magic? Let's unpack what's going on behind the scenes. Self-driving cars have a whole suite of sensors to give them a 360-degree view. We're talking cameras, radar, and ultrasonics, like high-tech robot eyes and ears. All this data feeds into an onboard computer powered by AI. The AI is the secret sauce, like a virtual driver with instant reflexes and complete knowledge of rules and routes. It uses machine learning to analyze sensor data in real time, recognizing objects and making smart driving decisions. Of course, the AI isn't born knowing how to drive like a pro. It needs tons of experience to master the skill, just like a 16-year-old with a learner's permit. This is where Tesla has a unique advantage. They have hundreds of thousands of cars loaded with cameras and sensors on roads worldwide. Each one logs situations it encounters while driving. When the onboard AI isn't sure what to do, it asks the driver to take over. These moments get flagged as errors. Tesla then groups these scenarios so its engineers can solve the problem with a new software update. The system is basically pooling together all this experience from a huge fleet of robot drivers. This data then trains Tesla's neural networks, constantly upgrading their AI's reasoning skills. The more cars they have on the road, the smarter it gets. That's why autopilot keeps improving in situations like blind turns and divided highways. Despite all this technology, specialized teams must oversee AI training from start to finish. Humans meticulously check how cars operate in the real world to ensure the system improves. The engineers design simulations and training systems to teach the AI efficiently, and as they do, the AI soaks up billions of miles of experience. Tesla then combines its data advantage with human ingenuity to create an artificial driving intelligence. This blended approach allows Tesla to continuously enhance capabilities through a feedback loop of real-world driving data. The human touch ensures safety and smart progress. To turbocharge computer learning, Tesla is constructing a cutting-edge AI supercomputer called Dojo. It uses specialized chips to process thousands of video streams simultaneously. We're talking about reducing training time from days to just hours. This will allow Tesla's human and AI teams to accelerate Tesla's progress toward full self-driving. Tesla's long-term goal is to achieve full autonomy so drivers can be completely hands-free. They're not quite there yet. For now, autopilot is considered an advanced driver assistance system. Anyone using autopilot will need to stay alert and ready to take over at any time. There are still challenges to tackle before full self-driving becomes a reality, like driving through complex urban environments and extreme weather. Tesla must also test these systems to prove they can handle uncommon edge cases like crazy traffic in New York City. But with their ever-expanding fleet, Tesla is unlocking more complicated scenarios every day to enhance their AI. In the end, even rocket science becomes routine with enough practice. Self-driving tech is almost ready to make transportation safer and easier for drivers. And Tesla's creative approach is accelerating innovation in the field. The next time you see one of their cars driving by itself, remember there's a robot driver inside that never gets tired or looks at its phone. And it's always eager to learn. Self-driving cars are just beginning, so hang on. It's sure to be an exciting ride. For those hungry for nitty-gritty details, let's dive deeper into how Tesla leverages advanced neural network architectures to train its AI. The autopilot system uses neural networks which are complex statistical models inspired by the human brain. These networks have multiple layers that transform input data into desired outputs. Specifically, Tesla employs convolutional neural networks, or CNNs, for object recognition from camera inputs. CNNs analyze images in chunks, picking up patterns and objects through successive layers. This enables robust computer vision critical for autonomous driving. Training these advanced networks requires specialized hardware like Tesla's Dojo system. Dojo's D1 chips enable massively parallel visual data processing to tweak billions of parameter values within the model. The autopilot system constantly runs on cars in a state called shadow mode. In this mode, it collects image data and looks for inaccuracies. Dojo then retrains the network based on what it found and sends the new models back to the fleet. This constant feedback loop of real-world data to refine the network is key to improving accuracy. With Dojo's speed, Tesla can retrain networks on newly harvested data in hours versus days. Plus, there will always be surprising situations. A school bus that stops in an intersection, construction workers holding up flags, a closed road due to flooding. These are all non-typical driving scenarios. Tesla trains for these rare edge cases using synthetic data generation and simulation techniques. The autopilot team has one simple goal: to train an artificial driving intelligence that exceeds human-level capability. Since so many Teslas are on the road now, the data each one collects allows the company to make this a reality. Thanks for joining us on this journey with self-driving cars. If you enjoyed this video, remember to like, share, and subscribe for more fascinating trips through our technological world. Until the next time.